can see the application process. You have to go to Digital Sky website, and like that, you fill up the form and give your like information, your unique identification number for the drone, your purpose, your duration. So they will update in the DigiSky if you get the permission. And next is radio telephony phraseology. There are different phrases to communicate with air traffic control. So radio telephony phraseology is nothing but some form of code. You can say a code and some form of terms that will be used for air traffic control pilots or people in airspace to like give communication to like a certain standard unambiguous communication will be there between them. So what are the key aspects of radio telephony phraseology? So when you communicate with that air traffic control, suppose you are a pilot and you are communicating with air traffic control, clarity and consciousness should be there. When you convey a detailed word or something information you want to convey, you should be clear about that. Some code, you should not mismatch that code. And standardized expression will be there. Some code form will be there. And phonetic alphabets, different types of certain specific alphabets will be there. Like suppose A for alpha, B for beta, something like that. And so you can see here different call signs. What are the meanings? What are symbols? You can check here. Suppose you want to call a truck. Suppose specific number of truck will be there and specific worker or driver for that truck will be there. So you will call that trucker 5, worker 21, like that, to call in that specific location for oil tanker or something like that. And these are a different word phrase. Acknowledge, meaning that is the let me know that you are received and understood the message from the air traffic control. Or affirm, yes, affirmative, like that. Sometimes you will also say, you are in an emergency situation, you are flying a jet fighter, and you are in an emergency situation, you are about to crash. You will say, you are heard in movies like, Mayday, Mayday, you will say. So that is one of the phrases for radio telephony phraseology. So these are the different unit of services and their suffix. For example, control center will call control, radar is generally radar. So these are the different things, meanings. So how to report a position like of your aircraft or your airplane and altitude. So firstly you have to identify your aircraft. There will be different aircraft, different number of aircraft in airspace. Identify your aircraft position, time, what is the level, altitude, and when like after certain interval you will again report again, like significant point like duration will be there. So this is the diagram. Here the pilot is saying first there, this is the plane name, and this is the nautical miles, how speed is going, and this is the flight level, 330 into 1000, there is 33,000 feet. And this is the intersection name. So the pilot is saying to the air traffic control these words, and the air traffic control is returning with this fast air 345 Roger that. So they got the message. And here, so the air traffic control is saying this again, and this the pilot is saying will comply with this message. So like this goes on in certain intervals. So next is flight planning procedures for UAV, where there are different procedures will be there in flight planning. This is in terms of survey, land survey. So KML, what does KML means? Anyone knows? Yes, keyhole markup language. So that is in terms, we can modify that in Google Earth, right? So KML is nothing but an area you want to survey. You have drawn that area and survey in the Google Earth, and you took that KML file, and now you will insert to the drone software, and whatever survey you want to do, you will do that. So then in area, in survey area, if you are marking control points or ground control points, why it is important? That is important because when you survey that area and you want to mesh that area, you want to create an ORI or auto rectified map to get more accuracy, the ground control point is required. So KML preparation will be there, identification of ground control points, which you will mark in the real world, in that survey land area, and preparation of flight KMLs. Like suppose you got a 7 square kilometer area, and your flight in one-time flight can cover only 1 square kilometer area. So you will divide that parts into 7 parts, right? So you have to prepare that KML also. And base station identification. In a drone flight, you will set up a base which will be connected to a satellite, and around that area coverage, it will give you more coordinates. So it will link to the drone thing. So, and marking of CP and GCP on site. This is firstly, you will mark this on Google Earth KML, and this one in site. So, and before flying, you should always examine the drone. If wire issue is there, or something error is there, if the wing is broken. Sometimes in transportation also, some defects might be, like accidents might be happen. So you should check that. And checking of batteries also before flying, if the battery is sufficient to fly that area or not. So identification of flight location. Identification of flight location in the sense, not that you already know the area, but when you go to that site, from which location you will fly. You won't fly from some dusty area, you won't fly in water. You need to find a hard surface and clear surface to fly that, like some sufficient area should be there, not in grassland. And preparation of flight on site. So you'll insert a battery, you'll do all the procedures that is necessary to fly. And mission plan. Mission plan is nothing but, I'll show in the next slide. After mission plan, we'll fly the drone. And after flying the drone, you'll get some data. You'll check that data if it is relevant or not. So next, this is one of the drone fly software. You can also integrate from mission planner software. So this is from a CD Space company, CD Flyweb software. So you can see here, this is a flight plan. So like this, you have to do a flight plan. You can see the zigzag pattern. This is nothing but a drone part. So drone will start from here and it will go like this. So one entry and one exit will be there. This home you can see. This is the location from where you will fly. This is the home location. Now, yes, geofencing this is. Yes. So this is nothing but a geofencing. From here, your drone can go outside this area. You have given the specified area. The drone will be flight inside this area only. And with this part, so you can see here camera. In the drone software, like for the drone, you'll integrate some camera, for example, Sony or any other Canon. So here in the software, you'll integrate, you'll name that camera. So here you can select if you have different drones from your company, like you have different cameras in the drone, so you can integrate that software. So the drone which we are using, it has Sony ZV-1 camera. So we have selected Sony ZV-1. And what is front OL and side OL? Overlapping. When the drone goes in this part, the image will overlap each other. So frontal overlap means nothing but drone will take photos like in this shape. This like as it will take, this is the frontal overlap. Side overlap is nothing but images overlapping between these two sides. So here frontal overlap we have given 75%. Like between those two images, 75% of the images will be overlapping each other. And side overlap is 68%. And here height we have given 119. You can also give 120. As DGCA said, above 120 you can go. And ground sampling distance is nothing but it will co-reference to the height. And takeoff altitude. What does takeoff altitude means? From one location, from that home base, it will go till some height. From there, it will gradually increase to the entry point. For example, from here, we have given 30 meters. Actually, we should not give 30 meters. It might hit some obstruction buildings or something. Suppose we keep here 100 meters. So what will the drone do is, from this location, from the flight location, it will go till 100 meters horizontally and gradually increase the height till 120 to the entry point. So this is nothing but takeoff altitude. And about the flight speed, this is in meter per second. So according to your speed required, some certain limitations are there, but we have given 10 meter per second. And this is the grid angle. Grid angle is nothing but if you slide this slider in this map, the slider will move around. Not move in the sense, the grid angle will change according to your liking and according to the wind speed. Mostly when you plan a flight plan, will keep the grid lines perpendicular to the wind speed. Why? Because the tailwind, it will hit the drone, so it won't consume more battery. And next is turn around distance. For example, in this corner, suppose the drone is going straight like this, and we have given turn around distance 0. So what the drone will do is, after reaching this corner point, it will just rotate and continue its path. But if you give turn around distance as 10 meters, so drone will rotate around 10 meters and go to its path. So if you give this, it will consume more battery. And rotate entry point is nothing but, here some entry and exit point will be there. We are just rotating. Suppose this was the entry point. If we rotate, this will become exit point like that. So follow terrain mode, I'll come to that. Follow terrain is nothing but a collision avoidance system integrated from the Google Earth or any other like terrain code, which it will just follow the terrain. You don't hit the terrain structure. So exit to capture is nothing but, if we go to exit point, it will stop capturing the photos. You hold, it won't move around. Crossfly is, as we saw grid line like this. What does crossfly means? It will just make a grid pattern. It will go like this second and it will form like this second. Where crossfly is mostly used is in densely populated area to get more accuracy and more clarity of that area after doing the photogrammetry work. And here we can see the different statistics. Area, this area was 0.472 square kilometers. Total area. Photo count, this is approximately photo count. It's saying like 325 photos will be taken in this area, but it won't be like exact. Photo interval, between two photos, like after 2.7 seconds only one next photo will be taken like that. Photo interval will be there. Trigger distance is between two photo interval, how much distance are there? So this is the trigger distance. So distance traveled is nothing but how much the drone will travel this grid line. There is 10 kilometers or approximately 11 kilometers. And time taken will be 24 minutes. Maximum distance from the home till the entry point, or till which radius maximum entrance is 561 meters. And the grid spacing is 53 meters. This is the grid spacing. It is 53 meters. So you can see all the statistics here. After giving all these parameters, you will just create a mission. Here, create mission, and the next will be like this. So this is the in action, the software, drone software in action. So here, from here we were flying. So it is going till the entry point. This was the entry point. These are different waypoints. So you can see here, these are the parameters. Altitude. So what is the altitude of the drone? 131. Because it was doing terrain modeling. In terrain, although we have given 120 meter is the maximum altitude, but in terrain mapping, according to the terrain, it will adjust its height. So distance to home is nothing but from this home distance, how much distance is the drone, and satellite count, how much satellite is connected to the drone. And this is the average satellite connection. It should be less than 1. And this is the battery voltage. Maximum battery voltage for our drone was 25.2. So it is dropping. And wind current also you can see. So all this param you can see, right? This is the customizable parameters. What parameter you want, you can customize that. And this is the ground speed. This is the time in air. This is the trigger count. And trigger count. And distance travel, 0.42 meters. Sir, actually, like altitude will be fixed for plain area. But if you give terrain mapping like option, what it will do is, suppose this is the terrain, and our drone is moving. So related to the drone height and to the terrain height, it will be 120 meters only. Yeah. So as we can see, we did one mistake in this. We have not calibrated the drone properly. So the compass is saying that. Well, if compass is saying red, that means like drone data, like it will not mismatch will be there. Some possible error might be there. Sometimes one case also is there is if you fly near high tension wires, the drone compass will also get disturbed. Yes, some current issue might be there. So you should be at least 100 to 200 meters far away from the high tension wires, or like radio towers, or any things like that. So next is collision avoidance system for UAV. So different collision avoidance systems in car also we can see, like sensors will be, it will beep if it comes near. So in that case also we can integrate different collision avoidance systems in drone. So sensor integration, like LiDAR sensors, to map around the area. If it detects an object, LiDAR is more accurate compared to camera, visual camera. So we can integrate that. But the problem with LiDAR sensor is it's very expensive. It's not economical. Then obstacle detection, like from machine learning also we can do with camera. Sir, yeah, if it is a DGCA certified drone, it won't go above 120 meters. It is, yeah. Yes. No, no, you can reduce also. Yes. You can do it illegally. Yeah, you can. Yes. Yes, it can do. Yes, upper limit is fixed. Like certain limitation will be, it varies on drone capability and like company what they sets. You can alter it, but it is some coding you need to be doing, but it will be illegal to do that. Yeah. If like drone is not DGCA certified, yet you can alter that in that. But if the drone is already DGCA certified, they will set a rules and regulations. Like if you cross that, then your drone will get discontinued, or will be seized, or will be penalized. Actually, like yeah, you can integrate that also because it is derived from open source software. There is mission planner. Yes. If you do some coding, like customize it for that. But this is already customized for like certain drone, their own drone. Yes, it is already customized for the like company, they supplied drone. Their own drone, CD space. Yes, CD space is that. Yeah. So collision risk assessment is also there. If you see far away, like tree or something is there. So that risk assessment, like from visually also you can take. Path planning and decision making also. While flying a drone, you should always be careful, like where you are surveying, your surroundings. It only doesn't depend on the drone. You should also be careful about that when you are a pilot. For example, if you are flying in an area, there are 2 or 3 hills are nearby there, and you are covering outside of the hill also. Like visually you have to see, like for covering that hill, you should do a certain terrain mapping feature you should give. And fail-safe features, different fail-safe features are there. For example, if battery is low, if it hits certain voltage, it will automatically come back to the launch location. And if, for example, sometimes what happens, drone is flying, and certain wind gust will come and it will like hit the drone outside of the path. Not hit in the sense, it will move the drone outside of the path. So if it is going stray for a long time, it will automatically come back. That feature is also there. And if the connection loss with the software from the transmitter to the drone is there for a certain period of time, for example 2 minutes. So if that connection loss is there, so drone will also automatically come back in that case. So this is one of the terrain mapping features. This is a video collision avoidance system. So you can see here, this is the flight path of the drone. You can see how the terrain it is mapping, how it is going to the hill terrain. So if we are giving 120 meter altitude, between this path height to this ground surface, it will be 120 meter only. So it will be constant 120 meter to the ground, not from the actual height of the drone. from the ground to the terrain, I mean to the drone path. So this is one of the collision avoidance system. There is terrain mapping feature. Sir, it's already applied on the software, but if you want to see this part, actually it is integrated already with Google Earth. In Google Earth, all the Earth's terrain features are there already. So directly a new hill can come up, right, sir? So that is one of the things. But one issue here is, I'll convey that. This is the hill. So in this hill, suppose sometimes what happens is, above this hill, tower will be constructed. So how it will map the terrain? How this drone software will know? It won't know. Either if it has like a sonar system or LiDAR system, it won't know, like camera. So what we can do is, the drone pilot should be careful about that. You see, like visually he should see and avoid that area. Although if it needs to be mapped, so he has to give some altitude, or otherwise what he has to do is, climb on the hill and then fly above that tower. Mostly the tower won't exceed from 80 meters, 100 meters, like that. So 120 meters will be fine. So all this practical software we'll learn it tomorrow in Presidency University. Practical session will be there. And so whatever more doubts you have, you can ask there, like in site itself. Hands-on training will also be there. So how to do UAV crash analysis? So how to do drone crash analysis? If the drone is crashed, in that, suppose you are flying in area, and in that location you have crashed the drone. So what needs to be retrieved and what needs to be visualized? It's like an inspection report. For example, crime scene is there. So how do you make report? Then drone crash is also in crime scene only. There's certain lakhs of drones is gone and crash. It's a huge loss. So flight logs data, like in airplane, if it crashes, black box will be there. Yes. So in drones also, flight logs, that black box type will be there. So we should retrieve that flight logs data. And physical inspection is there, where it is damaged, in which wings, if all the wings are damaged or only some part of wings, or motherboard is damaged. If motherboard is damaged, then gone, all the drone. And environmental factors. Suppose were you flying in a cloudy, or for example a rainy day, not rainy day, like in cloudy day when it's about to rain, or high wind area. This also contributes all in UAV crash. Flight path. I'll show you one case study next. Human error will be also be there. This is the case study linking to that port. So system malfunction. Sometimes, yes, it is a machine. It is not perfect. Sometimes overheating issue might be. Malfunction will be there. It is also contribute to the crash. And battery and power. You should always monitor the battery voltage. As you can see in this software, you are monitoring the battery voltage. It should not be less than 18 volts. Although it has fail-safe feature, but sometimes what happens, sudden drop of battery will be there. For example, huge wind gust comes, like opposing to the drone. It will consume more battery. So that also needs to be taken care. So, and rules and regulation compliance you should always maintain. So this is the case study. This is Polygon to Rock Mountain, which is situated in Chittoor, Andhra Pradesh. Yes. So this was one of the 100-meter project area survey. So what did one guy do is, one drone pilot was there. He was surveying this area. Yes, he was surveying this area. So what did he do is, he flight from this area. He didn't like inspect it properly, the surroundings. So he flight from this area and he was flying. So what will the drone do is, the area is here and he was flying from here. He thought that if he give terrain mode feature, it would have gone above this hill, but he forgot to give. So what happened is, you can see here, drone flight. It went till the takeoff altitude, and it was going to the entry point, and it went straight and it hit this mountain. So drone was crashed. That was human error and visual inspection error. So it was not a technical error. So you can see the radio here. This is the time and this is the altitude. Yes. So that's the loss. Yes. So that is a human error only, not in software error or any other error. So you can see the time and altitude. So altitude is increasing. Here altitude was increasing, and there's a time duration after approximately 6 minutes, it got hit and it crashed. Although drone was not switched off, that's how we could have retrieved it. The drone was sounding like beep beep, like that it was sound. So we could have retrieved it. Like here it was fully bushy mountains was there. So this is also one of the challenges. You should be very careful about it. How to avoid crash. So here also I have said how to avoid mishap while operating a UAV. Know the rules, always important. Check the weather. Weather where you can check. Although you can check in Google, but reliable source is Windy app. In Play Store you can find WINDY, Windy. So there you can check the weather patterns, wind speed in meter per second, in kilonewton or something different will be the precipitation also. So DGCA will say you shouldn't fly. They will recommend you shouldn't fly where the wind speed is more than 8 meters per second. So in 7 only you should stop. So you shouldn't get in accidents, drone accidents or something. And always inspect the UAV before flying. Again, one more case study. What happened with me is when we were flying, we didn't see the battery connection to the drone was loose, or soldering it had worn out. So what happened is we fly the drone. The drone consists of 3 batteries. So one battery was not connected properly. So the drone went up and it was flying very slowly. We have given 10 meters per second speed. So it was flying very slowly. It's around 2 meters per second. I noticed that it is flying very slowly. I thought, why it is happening? So I called back the drone. And later when we took out the battery and saw, the soldering was gone. So you should not make that mistake. It should be before flying. If I would not have seen that drone, it was flying slowly, it would have gone somewhere and some malfunction will be there and it would have crashed. So inspection of UAV should be important. Calibrate the flight before flight. So I've said that compass calibration we are not done, that's why it was showing red. So data will get error. It would not come properly. Keeping in line of sight while flying. Always inspect the area or surrounding. And monitor the battery levels that I have shown in software and avoid crowded areas. Follow the pre-flight checklist. There will be different checklists while flying a drone. For example, battery inspection and sometimes a body inspection or many other camera inspection if it is working properly or not before flying. If you are flying and camera is not working, then what's the use of surveying that area? It would have been, it would not take the picture also. Sometimes what happens in some cameras, there will be cover. The human error is that sometimes you forget to remove that cover only. So it is fly and when it came, time is wasted, 40 minutes gone. So that also happened with ours. Many mistakes happened, from that only we learned. So keep yourself updated, that's the main thing. Always keep updated with the rules, regulations, and different technologies. And it's a future advancement required in this field, automated unmanned traffic management system. Like in India, we have Digital Sky, as I have said before. In Digital Sky, it is not automated. Like we are entering the data manually. And live airspace is not there for drone. It should be developed. Advanced collision avoidance systems. Although LiDARs are there, they are very expensive. So how to make it economical like that and develop new, like with existing technology, how can you develop more advanced collision avoidance systems? There is also one of the research you can go. Development of sticker and speed limit. Actually, I have not encountered with LiDAR drone, but yeah, it will be there. Speed limit will be there. And development of secure links and reliable data. So drone will be flying around, but how to secure that? Someone can hack it, because it's an open space and unrestricted airspace. So you should develop like security measures for that. And integrating real-time data, updates of geofencing data. For example, like suddenly somewhere it will show like red zone, some minister is coming, so that airspace is restricted. So live updates directly, it should be. Widespread integration of simulation-based training. Like we should, to advance in this drone field or UAV field, to get our youth interested, simulation training should be there. To get them more interested in how to fly, how to, like what are the opportunities from that. So it will create an open door to them. So summary of the session is we understood all these things. So these are the references you can scan and tag. Some 3 to 4 references I've given. Air traffic control, rules and regulations, DigiSky website, and some of that. Yes, you can take a picture. Only 3 to 4 references are there. So that's it. Thank you. Any questions? Any questions? You can ask for discussion to discuss. Actually, if you are registered, like DGCA registered drone, you have to fly in yellow zone. You have to register that. Like application form you should apply. But like if you're flying in yellow zone, they have radar system. They can detect, but for low zones they can't. Yes, they might have, but in green zones they won't be able to detect. Like it is not like low also. Like you can fly in green zones anyway, but in yellow zones. Yes, yes. Yes, yes. It will be there. Yeah.
No questions. Okay, you can ask. Tomorrow we are going to take you all to the field visit to their university. So thank you, Bibanji, for your interesting lecture. So we have another speaker is waiting. After that, we can go for a tea break. Not now. Okay, after this talk. Okay, please.
Welcome, Nagurji. Good evening. We have with us Nagur Kani, who is a group head of Geospatial Technologies and Image Processing from Karnataka State Remote Sensing Application Center, KSRSAC. He will be delivering a session on drone equipment maintenance and rotorcraft operations and aerodynamics. Before starting today's session, on behalf of KSTA and on behalf of all of us, I welcome you, sir. And thank you very much for accepting our invitation to deliver this session. Before starting this session, I would like to give a brief introduction about Nagur Kaniji. He has completed his master's degree in Anna University in the field of remote sensing from IRS University, Anna, Chennai. And he has joined KSRSAC in 2016 and heading the teams of image processing, digital terrain modeling and digital terrain mapping and GPS surveying related projects. Under his leadership, ground control point network for Karnataka was established and high accurate digital terrain model as well as seamless ortho image base for entire state were generated as part of KGS program. A big round of applause to Nagur Kaniji for this. He is also heading the team of Forest Fire Monitoring and Analysis Cell, which support forest fire management to Karnataka Forest Department, and he is coordinating disaster management using remote sensing and GIS Prior, he worked in the Regional Remote Sensing Service Center, Bangalore, NRSC, for various projects. He is responsible for generation of various thematic maps. Initially, he started his career as a project associate at Anna University, Chennai, and currently he is heading many drone-related projects in KSRSAT, and inline department services also they are giving related to drones and UAV. With this brief introduction, I welcome you once again. Thank you very much. Nagurji, the floor is yours.
So, good afternoon, everyone. Yeah. So, thank you, KSDF, for giving this opportunity to share our work we are doing on drones and our experiences. And thanks for the nice introduction, sir. Thank you. So, we will start. There are two sessions, two topics we are going to discuss this session. First, that drone maintenance, and coming to drone anatomy, drone parts, then some applications of UAVs, particularly on the multi-copters. So, first, it is going to be a mixed up, because without understanding drone parts, you cannot do a maintenance, or you cannot do that. So there should be a little change in the schedule. So we will mix up, we are going with that. So anatomy, everybody must have studied. If you are studying your PUC or 11th, 12th in case of the states, for botany zoology, it's a study of a structure, generally anatomy, human beings or any plants. The study of structure of any organisms. So here the drone anatomy words they put, so study of about drones, every parts of it. So this session we are not going to have too much technical, it will be too much mechanical session will become. So the basic requirements of handling drones we may be able to see, and some of the applications we are doing, so what are the drones we are handling, we will explain to that. So we will start with that background. Okay. Now, see, drone means we cannot think only about drones. So drones are called in different terms. So it is the aerial vehicle or unmanned aerial vehicle, unmanned aerial systems, if there are multiple sensors are attached. So there are not only the aerial vehicle, there are communication systems there are control systems are there. Then the ground stations are the GCS, ground control stations are all together. It's creating a drone system or unmanned aerial systems. So not only to that, if the drones are very long range drones, for the communication everything, in case of the military drones, they will rely on even satellites. So satellites also a part of the drone systems. Except the GPS, anyway, GPS satellites by inbuilt, they are part of the drone system. So other communication satellites for military purpose also part of the drone systems. So we'll go in detail the communications, how it is going to happen. So this typically the multi-copter we are going to see here. So the model what we are seeing is the Tunga Trishya Pro. So we have actually get the Tunga system, they are manufacturer. There are multiple kind of drones you must have earlier classes, previous sessions you must have seen. Now what we are talking here is all the professional survey grade drones. They are typically around 4 to 5 kg. They are coming under small categories. So they will have minimum payload endurance of 1 hour. So there are, but if there are nano categories less than 250 gram, so that we are not using, because basically we are a mapping agency. We do a lot of mapping. In addition, all the surveillance, other activities we are able to do. So as I explained, there is a ground control station. This ground control station consists of a communication system to send and receive. Then they typically should have an antenna. So what is that? The radio communication is happening. So the radio antenna is there. So the radio channel is 2.5 GHz. That is the open channel for Government of India working. Only you can 2.5 you can operate any communications to that. Anything beyond if you are doing is not allowed. It's not correct also. But the ground demonstrations you are doing is a typical system. Nowadays, all are big into a small, handy, because the antenna becomes more robust. So it will be like your modem, your Wi-Fi modem, only two having. So in that only the entire the display system will be part of that pad. Joysticks all will be inbuilt on that. So nano dots already they are existing because they are small. There is communication, they are not getting a big antenna. But in the large range systems, you have to have this kind of big systems without for continuously getting the communication system. So LOS should be maintained perfectly. The range should be continuously there for a long range system. So it is required in that context also. Still, people who work with the big antenna. So this is anyway. I think we'll have a better picture. We'll explain that. So coming to drone anatomy. So battery is major part. So the battery, if the endurance, if you want more, the battery weight become more. So typically for 1 hour endurance system, the batteries here, this lithium ion polymer battery around 1 kg itself will come. So they are more easily detachable. They are more easily actually handled. So that's why this system will be always they put it on top for how can I say, for handling easiness. So this system is come with very simple, even it does not have a cover. So there are some drone marks are doing different way. So to reduce weight, reduce cost, all. So but it is working well also. So we will first be afraid that it is just attached with only one tether, but still able to do every work without any issue. So it has a battery, it has a motor, it has a GPS. Obviously GPS is very important to that. It will have a minimum 2 GPS, onboard GPS. Apart from that, the GPS is normally single frequency GPS. Yep. So if you want to do a professional survey grade drones, the GPS should have a multi-frequency or minimum dual frequency receiver. So it will be able to receive multiple channels. GPS system from Galileo, Nowstar, GPS that is ultimate US, even Chinese. So we are having that kind of system because it's for a mapping accuracy, precision mapping, it is required. So in addition to the existing GPS, there will be a high-end GPS will be on the board. We call that as a PPK enabled drones. Post positioning kinematic. So there will be a base will be established on the ground near to the ground station. So we will do the corrections later, whatever at the time of mapping, positional corrections of the satellite, that drones and sensor. At the time we can do that, so we can able to create a proper 3D models, orthophotograph, digital elevation models, everything. So the propeller, arm, antenna, payload, so landing leg, these are part of the vehicle. We are going to see little bit details about that. So motors already, most of the DC motors only. So there are two motors generally people will be talking. So brushless motors and brushed motors. Now all the drones almost coming with the brushless motors. So it is nothing but that rotation of the motor is electronic. That's it the difference. We will knowing this much also enough for this, because we are not going to too much work on motor maintenance part of this. That will be do detail. That has to be given, if that kind of repair required, that has to be handed over to the agency, OEM manufacturer, authorized the service agency. Okay. The propellers, so everybody knows the propellers, it's a blade, so it will cut the air, it will create the empty above the drones, so it will create a pressure difference, so you must be knowing that. It is required. Then flight controller, the flight controller, it takes all the inputs and it directs the plane. So it is as a GPS module, it will have available sensor, it will be linking with everything, and remote control obviously. So our communication will be linked through the flight controller. So it's basically, it is a brain, it is an important part of the flight controller. So it will have a autopilot mode, it has a different kind of pilot mode, everything command control structures, everything will be inbuilt into that for the navigation, flying, mapping, everything. Then one more is electronic speed controller, we are talking one more device. So through this the speed will be controlled, the power will be controlled. So for that purpose, so the name itself indicates that. So power distribution board. So this it's like a motherboard of the computer. So it will connect all the electronic components of and draw power from the battery to give. So the motherboard is the basically it's a motherboard of a computer. So it will give all the electronics parts will be embedded into this. So camera, next come to the camera, payload, sensor, there are same terms. So typically there are two sensors mainly for surveillance and survey. So surveillance, so that is video photography. So anything the real-time video is required, it will be going to capture. And thermal, there are multiple payload we are going to talk. So thermal sensor will come. So it is also having a video photography. Then coming to the mapping, same thing with the photogrammetry payload. So to be able to, it's a still frame camera. It will be used to collect picture from multiple angles to create a orthophotography and digital elevation model. And we will have agri drones. So the payloads will be different. So even forest fire, we are trying to use fire extinguisher balls on the drones to arrest small forest fires. So the payloads will have multiple applications. They are totally different. Depending upon our usage, we are going to use perfectly and maintenance accordingly. So basically the cleaning will be the maintenance of all the payloads. We are not going to do much into that. Then gimbal. So gimbal is a mechanical mount. It will enable movement and stabilization of the sensor rotations. So it will, we can give the any rotation record, any movement through all three directions. We can move that. So gimbal will help to that. So gimbal will be controlled to the flight controller. We can do that. The frame is the skeleton of the drone. So everything is going to be attached to the frame. Having a GPS, same chip will be on this also, except for the survey grade drones. But it will have a minimum 2 this. Because of any failure, the redundancy will be there to avoid any mishap. So even though failure, there are mechanisms are there in the drone to come back safely. There are safety measures, the class they will try to explain, return to land, return to home, everything that will do that. Still to avoid any delay, the redundancy of GPS will be established. That will be a small round object will be there. So it will be able to give the positional accuracy up to 3 to 5 meter it will provide. So if you are okay with that accuracy, we can work on that. Then remote control receptor. So it is the sensor which are receiving signal from the remote controller. These are part of that. The remote controller. So they provide the link between the user and the drone. So they are similar to remote controllers. What is the difference is they have more sensible because they have to work on it. So they are more sensible and more robust. Then coming to the output of it. So the video transmitter is required. So whatever we are doing, whatever the drone see, it has to be communicated in real time. Otherwise there is no use of it. For most, there will be use, but not the immediate use of it. So for that, immediately has to be transmitted. So the transmitter can happen if a small distance, anything, they even have internet enabled drones are there, they are nano drones they will have. So, but for long range, everything you need a radio wave communication. So we should have that antenna. With that antenna, only the transmitter, video transmission also is going to happen with a different channel. That's it. So the same that company is having the RF frequency only through for communication, control, as well as the video transmitting or photograph, whatever we are capturing, everything to the system only. So next coming to FPV or first person view. So it can be a goggle or it can be a system what we are able to see in the laptop or tab. So whatever the drone is seeing, it will be seen to us. So these are the basic terms we should understand when talking about drones. So obviously landing gear, most of the drones the landing gears are fixed. There are two frame will be there. So, but if you are buying a high-end drones, typically for a fixed wing all, it will work like aeroplane. So the landing gear will exactly come out, it will land, this kind of things are also there. Okay. Now we will going to see just whatever we discussed in picture view we are seeing it. So this is typically a ground control stations consist of communication box, so tripod and cable from whatever antenna receiving it should come to the laptop. The joystick, they are nothing but a remote control. So what the communication box do, what it does, typically what it does. So the communication box definitely should have antenna. Antenna will be two types, patch antenna as well as the omni antenna. This omni antenna is 360 degree, it can receive and send the signal. This patch, but the range will be little smaller. That the communication range will be the smaller. Patch antenna will have a it can able to receive signal from the or send signal to the large range. So typically now our drones are having 5 kilometer range. This antenna is good enough to have without any LOS, loss of signal, or one way the line of sight, both will be the LOS, we can see that. So with that we can do the long range mapping. So for us we have to do the continuous mapping of the area. So in that case we use that fully. So obviously you should have a power, should have a power port, should have a communication input output channel. Here nothing but this Ethernet communication. and it should indicate the charging capacity. So every communication path typically have this. So we will know that when the charging comes, we will see how what are the things is required to do that. So it's a typical controller or joysticks. So we can, this is Tunga system, their operation. So we can see the throttle up and down. So yaw left and right, what is yaw, pitch, roll, next I will explain that. And the throttle is, it is up and down. The lighter means it will be stay safe, without disturbance it will be safe. It's a lighter in English meaning. The disarm will do, the joystick will become inactive. So the disarm will, because when I put a autopilot mode doing surveying, should not unnecessarily give any command. So the disarm will help me into that. So this roll pitch yaw is very much important to understand, to control the drones, as well as in case of if you studied photogrammetry, if you studied the stereo data processing, for that also you have to measure the roll pitch yaw to process the data very accurately, effectively. So the rotation across the axis, typically x-axis, y-axis, z-axis, will have that's a roll pitch yaw you will know. So the control will come to know that. So each we have this, the joystick will tell. So any controller will have typically this kind of control systems. What we are seeing is the Tunga systems, their controllers, drones and systems control. So roll drone, if rotate like this, roll, okay. Roll will be, if going down and up, it will be pitch. Yeah, if this is. So all three will be the rotation. So we have to measure all three. Otherwise the drone will actually will come invert, it will fell down, it will lose, the antenna become, if not available there. So all the things going to happen and to what extent. So it is very much required, the gyroscope on the system will give measure these angles, everything. It will help us to make the drone more stable, straight, or as per our requirement also. So propeller, so there are, in case of a quadcopter, there are 4 propeller will be there. 2 will be clockwise rotation, it will rotate whatever. 2 will be anti-clockwise or counterclockwise. So this is very much important while doing the actually assemble. So we have to do a properly. If you mismatch the propellers, so it will crash it. So even we are seeing that even well-trained pilots, they are sometimes missing this. So even though they have given same color codes, everything is given, both the end, the screw will be one color, red or blue, everything, but still it is going to happen. That's why in the maintenance we are going to do what are the checks is required. So there we will be able to a little bit, we should be getting habit. So all it is like driving a vehicle, it is obviously everybody knows that. So we have to have a more habit about it. We should do the simulation, lot of simulation softwares now coming. So we have whatever the drones we are using, you have to use the simulator to get it full control. So if you want to be a drone pilot. Okay, now we have so far we talked about what are the drone parts, so drone anatomy. So some terms are there, so many abbreviations. So I lastly, if you have time, I will go through it, otherwise it is very much available. So what is LAS, what is UAV, unmanned aerial. So these are abbreviation glossary you will get everywhere. So, but right now I wanted to give the brief intro about all the major parts about the drones. Yeah, basically required for a drone pilot or drone operator to know it. That much only. Too much electronic parts we are not discussing. We need not to discuss that also. Anyway. So there is maintenance. Why it is required? If you not do, what will happen? So maintenance we have to do all the time. So what are the frequencies? What is the schedule? What kind of maintenance is required daily or bi-weekly, monthly, yearly? So that we are going to little bit discuss. So maintenance tools, small tools, what are there coming with the kit, we may able to discuss a little bit about that. So am I audible to all? Yes. So what maintenance what we are defining? The set of activity to ensure proper running of equipment and system, ensuring technical interventions taken at proper interval with proper expertise. So it is classified into two mainly: preventive maintenance, corrective maintenance. So what is preventive maintenance? It is understandable. So it is scheduled, pre-planned. So we know if we miss what is going to happen. So that is preventive maintenance. So it is not only failures, even reduction in the capacity, everything. So in case of speed, case of control, everything. So it need not be always a complete failure. Any slow performance also, it should be able to detect and do that. Corrective maintenance. If something happened to that, how much we fail to do, what kind of level we may able to do that. So there are more than 20 typical checks are there. That's it. So if you able to do it properly, the preventive maintenance can be done properly. So what are all they? So first things, who is going to do the maintenance? So we cannot hide. So the person going to do the maintenance give the proper detail which he is going to do. Everything should be recorded. Then structural inspection. So most of things are visual inspection only. The maintenance what we are going to do that. So we have to see the cleanliness of the chassis, whether mud and dirt are there. So for cracks we should do that inspection. And anything screws, anything is having loose, we have to tighten it. Propeller for damage. See, the propellers are very prone to damage. So we have to check all the time. Whether it is rotating free properly or not, so that you have to check the freeness of the rotator. And we may get some foreign object, insect, anything, any debris, we are flying, it will happen, we might not even know. So you have to check everything properly. Anyway, wiring and soldier joints. Most of the drones, the boards, everything actually openly available. Sometimes they will not even cover it, they will not record. So with that case we have to check it. Even if it is covered also, it is detachable, we have to open. We have to check for clean for dirt. Because obviously dirt will and mud will going to come. Because it will, whenever take off and landing, it create lot of dust into that. So the drone will obviously going to get that. In generally they are not vulnerable. The drones, the high-end drones are designed for that, but you cannot accumulate continuously. So you have to do the proper checking into that. Then, camera. So camera is only lens clean. That's it. So mostly you have to properly then it is working with the rotation, everything working or not. So landing gear condition. So here landing gear nothing but a frame. Without crack it is there or not, we are going to check. So check control station for faulty components. How we are going to do, you may able to, I will explain. So for charger any damage, battery any damage, if the lot of uses everybody knows battery become bulge, so we can check that. That is the easiest way to check the battery. Or leakage, we know that battery will become, the leak will be there if it is damaged. So those things can be checked. The important thing is we have to check everything. We should not miss even one thing. That's why there is a checklist. Otherwise, need not be even written. Why you are returning? We should not miss anything. So that's why I am telling you. Even people are flying so much time, they are missing something. After in mid of fly or something only, they are coming to know something. They can some mistakes are not even reversible. So sometimes happen. So charging batteries. So charging batteries is important, otherwise we will go deep inside the forest or something. So we will at the time of that, it looks like small thing, but people will be missing it. That's why the maintenance procedures are established. Whether it is small or big, we are going to end up in doing everything perfectly. So it is very perfection is required, like how to flying the aeroplane or any aerial objects. Except here damage is actually not human damage is happening most of the cases. That's it. Otherwise, the sensitivity is remains same to the actual aerial vehicle. We are talking about the drones are having professional, not the nano category drones. Something we are talking here. So okay, you can ask me. The maintenance, everything I can do? No. Everything a remote pilot or a basic cannot do that. So basically the pyramids are 3 levels are there. So it is a organization level, that means our pilot level. So what we can do, the user level that is. That intermediate level, if you are a very good remote pilot, so you have with additional effort, we can do that intermediate level of maintenance. Then depot level, it is the OEM, they can able to do those replacement, overall something. So there are basically any maintenance will be part of 3. So what is same thing? What is organized level? It will be performed by flight line personnel, scheduled inspection by servicing, rapid repair of discrepancies noted during or between flight. So we are checking the any discrepancy. What is intermediate level? It involves more extensive maintenance work. Major detailed inspection is required. So component repair will do. Depot level is beyond that. So it is like more a manufacturing level. Any corrections is required. So not only this. Sometimes you have to have a special maintenance. So they are not very frequent, but it will be 6 months or yearly, because depending upon our usage. If the usages are more, then we have to have a special maintenance. So if you don't do, it will affect the overall serviceability. So maintenance is storing also part of maintenance, not only cleaning. So how to store it? How to store each component? If you are not doing any flight, if you are not doing for 6 months, no operation you have not planned, how to store it, everything part of the maintenance activity. So each manufacturer will provide a complete manual for their systems. Generally they are same, but depending upon that modules, components involved in that, the procedure will slightly vary. So that we have to study part of the at the time of you are procuring the drones, the OEM will do that. That is typically 1 week training they will provide. Apart from, I am not talking about the remote pilot license. It is only for handling the drones. So typically some timelines schedule we are talking here. So battery anyway full charge, everybody knows we have to do first full charge. any battery, so we will do that. So that is already in our head, it is there. So recharge and monitor battery voltage every time, how quickly it is going in. So every time battery recharge will be after flight. So that is mandatory, every time we have to do. Propeller, we have to do the visual inspection, the tight check every flight, before and after. Before flying also you are doing, after flight also you have to do. So we cannot be a little careless or something. It should be, it is very, very critical. Propellers is very, very critical. So whatever before and after each flight, it is very much critical reference. Then motor. So motor visual inspection, any dust is there, free rotation is happening or not. It is also before and after each flight. So landing leg, so they are visual inspection, whether it is fully tight, any crack is there, any damage occurred. So joystick or remote controller. So if you are using, typically 1 year is okay, the remote control. If you are a rough pilot, you have to do it little frequently, you have to do that. So it is how you are handling your drones, it depends upon it. So it is on condition. There is no time. So battery. So we have to check. So this battery chargeable is little different from a normal chargeable. It is a balancing charger will be there. The battery will be, multiple cell systems will be there inside the battery. Depending upon the drone endurance, 6 cell, 8 cells, 4 will be there. So 1 or 2 I can show that. So always the capacity of the battery should be 80% more. If it is not even charging 80%, we should replace. So it has to be there. So typically a 200 charge 300 times, it should be recycle it. So there is a discharge also, it should be there. If you are putting your drone for a long system down, you have to discharge the battery, you have to remove it and keep it idle. So all things will come in the manual. So we have to keep it, this checklist we have to remind it, we have to note it down, every action we have to do that. So landing leg, if in case of any issues, otherwise 300, 500 landings, now every drones are capable of doing that. So we have to send every 1 year, anything overhaul required, we have to send to the OEM for any further complete overall, any damage assessment, everything that has to be done. So communication by GCS bar depending upon the issues. If there is communication by GCS, we cannot do much on maintenance into that. So only dust and things. We cannot sit and put screws or do electronic or nothing. We should do that because sometimes it is working, but in flight it may give the problem. So we will end up in trouble. So that has to be clearly done by the OEMs or an authorized service agency for the purpose. So what is required for this maintenance anyway for battery charger? So that it will do the charging, discharging, cycling, there are all that buttons, modules, everybody available. So balancing, charging, everything is there. So we have to do properly. That is enough. That charger itself acts as a tool to check everything. It will give every vital information required for verification and checking. And GCS battery charger, typically for battery, for communication box different, for because it is on ground, so it will be charged separately. Battery will, onboard battery will help for powering the payloads, powering to the online systems or onboard systems only. So some figures here we are seeing it. So this is Tunga Systems, their battery. So it is a 6-cell battery. It is 8 amps required input. So these are the component: battery, power cable, charge the power cable. There is a balancer board. So to increase the capacity of the battery, there and the charging should be also having well balanced. So they are using the balance board for that separately. So without that also you can do charge, but it is recommendable to use the balancer into that. So it is organization level we are doing. So this is the way typically communication parts recharging will happen. It is low consume power compared to the battery required. So we can use that. It's only 3 cell battery, 1 amp is enough to have a full charge power up. So any indicator, always all battery will have indicator. Low indicator should not be red. That's it. So has to be. So anytime 80% of the before starting the flight, 80% of the battery should be power should be available. So that's it. So now intermediate level landing leg replacement, motor servicing, propeller servicing, data intermediate maintenance. So what we have to do for landing? Ensure payload battery floor are removed from AV. So any activity you do, we have to remove propeller battery. So that is must. So we have to remove that. We have to keep it on the level properly. So we have to check for any dirt or obstruction in case of motor. Same thing, ensure free rotation. So all I am doing, so what if something happened, what we are going to do? So that also part of, so there is a crash happen, harsh landing happen, how we are going to do, what is the procedure required? First, anyway right now all the drones should be above micro, should be insured, third party insured. The insurance is part of DGCA. I think you must be the class. So you have to take proper photograph, proof for collecting. You want to claim any insurance of you if you have done it. So everything has to be properly done first. Then remove the battery. Second, without any hesitation. Then remove the propeller. So if battery is damaged, it can be explosive it is, so you have to keep it this isolated. Then you have to convey to the customer support, whatever in case of that. So this is typically anything happen. So we should know what we are going to do in case of that. We should, because if you hide also the flight parameters, logs, everything will know which command we have given, everything will be actually recorded. So every activity, every control will be already recorded in the systems, in the log will have that. So all the operations, so whether it is the system failure or it is operator, remote pilot failure, everything will be easily detectable. So anyway, so that is the information we are going to have. I think mission planner will talk a little late. Tea break now? Okay, we'll have a tea break. Yeah, please go. Yeah, you have a OEM, you are a manufacturer, that is that. They have, all are establishing, sir. Everybody, because it is a continuous process. So now, that's why we are talking about the drones of small category, big drones. It is required. Some micro category are nano, they are not as well, but big manufacturers required. So that drones, even part of when you are procuring itself 1 year, 3 year, you should put that. So as a government agency, sometimes we may not able to do it. So we are going with that options for better continuous usage and with less cost for any maintenance and operations. So they have a system. They are established. All the big drone manufacturers in India, they are having it. We are using it actually. So, okay, then after tea we can discuss further. Okay. We had our maintenance break, so anyway now we will continue. So next topic will be the mission planner. So far we have done the last. So mission planner. So it is also, this tool also will help to do the maintenance check, all the checklist, everything. So typically it is the web interface or a system. It will give us full detail about the drones. And sensor system, everything, whether it's working well or not, everything we can check through the system. Okay, so if you want the battery percentage, it will come to know in this software. So then the voltage, so typically it should be for this 22.5 volt, then less than 18 should not be there for flying. So those kind of information that Mission Planner software will give us. So we can switch over from pilot modes, and typically you can view our videos coming from, our images coming from drones, everything. The system is part of the ground control station system. And so the GPS position, so current mode, what kind of mode it is flying. So the next, so typically this is the web page. So this is the Mission Planner software for the Tunga systems, the drone system. So they have given everything. So home, okay. So these are the modules available generally. So the actions to target, guided mode, any actions. So video starting, record, stop, photo on fly. So typically all the camera or mobile camera, what are the actions we can do, all we can control from here. So there are video can be recorded in two ways. In the drone itself there will be memory card or storage system, or some system will record on the ground station. So both way it is possible. So obviously there is a base map required. So we will know where we are planning, which location, what is the area for even for surveillance, mapping, everything. We can plan it here. Whether it is coming under green zone, yellow zone, all you must be now using the interactive aerospace map. We can able to see that. It's a dynamic map. We must be already covered in the previous class, I believe. So switch between the, if you having the dual payload, some payload will have for day camera and night camera. It's nothing but a thermal camera. You can switch over between the video simultaneously. You can parallel view. All can be done in the Mission Planner or controller things. So it will tell you whether it is autopilot mode, what is the aerial position, what is the range from ground station, what is the height, altitude, everything will have information in that Mission Planner. So typically one status bar will provide speed of area vehicle, distance from home point, there is nothing but the GCS station, home point. So every starting of flight, you have to record what is home. So we have to tell the system, because in case of failure, it should come back. So that is anyway part of safety measures, or part of drone operations. We will learn in detail. That class will cover. So here very much you have to see that two kind of battery status is required. Not only drone battery, your ground station battery also. So you cannot miss anyone. So very important in the maintenance the propeller installation you have to do properly. So you should not the propeller in the clockwise propeller should not attach with the counterclockwise propellers in case. So that is very much important, very critical. It will crash it immediately. It will fly and it will dump. So it will cost us more. So one important thing is has to do is a campus calibration. So how the everybody having the mobile phone, there is a campus app is there. Okay. So so how you are going to calibrate? If you open your campus app, it will ask you to calibrate. So you have to tell, it will ask you to rotate like 8. So it will be doing that. So once you rotate, then compass will get calibrated. Similar way we have to do the drones in all the direction. So it is recommended every flight, before flight it is recommended. So compass is part of the pre-flight check. So compass calibration is made. I will show some videos. This how the compass calibration is going to done. So this we will clearly tell about the battery and its capacity. So whether recycling required, what is the continuous maintenance of capacity, everything will be come to know. So the machine planner software will give all the inputs digitally we require. Some of the things we will come to know from the component itself. Okay, so something will come to know using these softwares or connected to the systems for the maintenance. Same thing. So here there are extra zoom in, zoom out, all the buttons will be there. So slightly it will vary from system to system. Most of the drone manufacturers maintain the same control, but sometimes it will vary depending upon the payloads mounted on the drones. So part of maintenance, joystick control checking is important. So every movement is working properly or not, you have to check it. So before each and every flight, it is part of maintenance. You have to keep it ready. So the tools will tell each tool is working properly. The command what you are giving through hardware properly read by the system or not, a drone controller or not, will come to know. So this will help us to calibrate the remote controller or joysticks. So there are so many checklists apart from maintenance is there. So anyway, UAV compliance as per DGCA rules, it should be everything is properly or not. We have to check part of any drone fly maintenance or whatever. Then routine maintenance are what we have talked. Full, regular, irregular maintenance, and some troubleshooting we have checked. For a new drone setup, first time flying, what has to done, there are checklists are there. For testing, how to test a drone, proper checklists are there, we have to learn that. So safety itself is separate and important feature to know, important rules to know that. So that is part of that. The repair, if you are having more interest on repair, not only maintenance, we can able to do. I am a mechanical engineer, I know little bit more, or I am a electronics engineer, I will know, so I know how to soldering, I know what is controller, so that can be done. So apart from that, one more important step is the updation of software and firmware. in the system. So the manufacturer, the OEM will be keep on updating. So like we are updating our OS systems, everything. So what is the firmware? We are talking two updates, software update and firmware update. So anybody can tell what is the difference between software and firmware? Okay, firmware is nothing but its software or set of controls given to the system, okay, in a microcontroller. Okay, it is a predefined. So it is also set of software control rules only. It is inbuilt in the microprocessor. It is inbuilt in the non-volatile memory. Okay, so how the return to home works? If the GPS fails, everything how it is works. This part of that firmware. So the firmware should be properly upgraded every time, updated every time. So there are procedures to do that. So you are nothing but you are giving new controls to the microprocessor or microcontroller. They are inbuilt in the system. So that firmware upgrade is very much important. If you are even same happen for GPS also. Any instrument of GPS, drones, all will be coming with the firmware updates. So software only, not firmware update. So most people will do that, miss that. Okay. So that will help us new modules if comes. For example, GPS if you take, a new set of satellite constellation is, the signal is able to receive. You have to update the firmware of the hardware. Otherwise, the new constellation will not able to be received by the existing system inside the cell. So if they are providing at free of cost, you can take it, or whatever if it is very much important update, you have to take it. So software firmware upgradation, updation is with the part of the systems. Inevitably we have to do that. So drone checking, pre and post flight is part of the drone flying. It will come. You will eventually, definitely you have to know that. So I will close this. Then we will come to the types of drones we have. Then what is the applications we are doing for Karnataka? Okay, I can show. So canvas calibration. So it will calibrate the magnetometer on board. So same way we have to rotate the mobile. We can do, but a little bit more exercise or rotations required. So you have to rotate with different axes, exactly where the axis. So you can see that. So otherwise the bearing will not be measured accurately by the system. So if you have a mobile, Android will tell you how to calibrate your mobile cameras. Company. Okay, so I think we don't waste much time on that. Sorry? It's recommended. Cameras, it's recommended. It takes 1 minute or 2 minutes extra, but it's required. So it will, because we don't know. So that recommendation is every flight we have to do the calibration of the camera. So I think some sessions getting overlap, some topics anyway, just some types of things we have to talk. So in India, there is a classification is not based on size, it's based on weight. So any drones is classified into 5 categories: nano, micro, small, medium, large. It's depending upon the weight. The weight is the total weight, including the payload, everything, every control weight. So typically a multi-copter will have a 1 meter, actually the diamonds 1 by 1 meter. Fixed wing have 1.52 meters, so that will be the size if you talk about that. What the small category drones, we are using for our mapping and wheeler purpose with the high endurance. Anyway, so since type of UAVs, so multi-rotor drone, the most famous one, particularly quadcopter, everybody is known about that. Fixed wing drone. Fixed wing drones are now, they are actually little bit, they become fixed wing VTOL. They are now, there is, earlier there is full, we need to have a small airstrip or a small runway required, a small place required to do that. Now all are coming with the VTOL, so it will be act like multi-copter while taking off and landing. For take off and landing, both it will be act as that. Yes. VTOL, vertical takeoff and landing. So now Trinity, F90, so many manufacturers, India all become VTOL. So fixed wings means now almost all the fixed wing drones manufactured with VTOL, because there is because you need little bit, at least that much area records, and landing also you record. Now people will just in hand they will take it off. So it will be able to, so if you are expert, you can easily while landing you can catch the drones and keep it, even with the fixed wing, because of this VTOL capability. Okay. So last one then. So anyway, different what are the types of drones is available? So we are going to discuss that. So single rotor drone, they are typically a helicopter, same system how it is work. The size will be different depending upon the drones. So drones also it is there. So it was. So some pros and cons is have to be discussed. So we are discussing that. So what is it? It is with heavy payload. It can handle actually single rotor. So it is faster than multi-rotor, no doubt. It has a longer endurance. What is that cons is? It is less weight than fixed wing. So it is having the endurance, but fixed wing have a more endurance. Since it is heavy, should have a large blades. These blades have a little danger. That's why handling single rotor is very difficult compared to a multi-rotor. So it is difficult to fly. So now coming to this session, we are most oriented to the multi-copter drones or multi-rotor drones. So if these are the terminology is used, tricopter, quadcopter, hexacopter, octocopter, so that terminology you can see how many rotors are there. So generally a quadcopter is a well balanced one. People are using it effectively. We are also buying, most of things are quadcopters only, using it. So it is easily, handling is easy. So we will learn very quickly the flying everything. Because of the fixed wing, you have to have more careful while taking takeoff and landing. You need you have to look for a obstruction-free area, larger area, everything. More flat surface. But here for multi-copter handling is a small a 10 meter by 10 meter size will be good enough to handle for a pilot, normal pilot. So they are able to hover. So any place they can hover very easily. Fixed wing hovering is very difficult. Compare this, but so land vertically. So you can move all the direction very quickly. A fixed wing, you have to rotate it. You have to have a U-turn you have to take. So here that is not there. So what is that? The speed will be little lower than that, it has a shorter range. But nowadays, the long range multicopters are coming. So typically a 5 kilometer range of multicopters are available under small category. It is the so obviously it have high power consumption, so the endurance is going to be less. That is the big difference between the fixed wing drones and this. So same thing what discussed, little detail is written here. So greater maneuverability is there. So design is compact, ease of use. This very important is cost effective. So if you want to buy, it is less cost than the fixed wing drones. So that is one major thing. But the fixed wing don't have its own advantages. So depending upon our usages, we should choose the system wisely. So if you are using the surveillance mapping means what kind of mapping, everything. For example, we are now doing one big project for entire Karnataka for all the building stone quarries is mapped. So the quarries are small pocket. They are typically having a 5 square kilometer area. So there are all multicopters only can do the survey perfectly than the fixed wing. So depending upon our applications, your requirement, we should use. For the long endurance, fixed wing is required, long range, so it will can able to support that. Same thing what we discussed. So now currently these VTOL fixed wing drones are there. So now which is best, the concept is little bit fading away. So the drones, the fixed wing or multicopter, now they are trying to manufacture with the same efficiency. So it will be, after some times, the gap between the fixed wing and multicopter will be reduced. So we can use anything for both operations. Even we will not even say specifically, our requirement will giving specification, we will not say it is for fixed wing or multicopter. You can, manufacturer can quote anything for that. So whichever cheaper, we will get it like that. So now hereafter it will be, both will be there. So VTOL will be always part of the system. Okay, some applications of drones, it is also listed. So there are, it is n number of applications we can talk. So it is, since it is able to capture beautiful pictures, high resolution, 2 centimeter, 3 centimeter spatial resolution pictures, so it can be used in so many ways. So photography, video, even people taking for selfies. So everybody know now, everywhere, all the marriage halls without the drones, it's not there, so all are happening. So it is used everywhere now, started using. So create building models, so real estates also. So all the big giants, they will, how to give their property to the public. So they are having with multiplied drones is helping them. So agriculture, anyway separate topics you are going to, it will be discussed for precision agriculture. So spraying, then monitoring health for using different payloads will be done. So emergency response, search and rescue, disaster zone mapping, so firefighting, so monitoring of poachers in forest. I just give something. Then obviously the delivery, that will be the future. We believe the drones will be used for part of delivery very soon. It is going to happen when the properly the system established, air traffic systems established properly, the rules and regulations will they set up. After that, using the UTM, unmanned transport system management, we can do the use of UAVs for day-to-day activities. Maybe after 10 years, it may be expected. Vulnerability of what? Yes, yes. See, vulnerable means, see, for there are two things. The real time, what is the current scenario? Already. Prevention, it is a mapping. So the mapping can be used for all the planning. Since that vulnerability is one planning. It's a prevention activity. So now we are using for trying to use for forest fire management drones. So forest department in Karnataka. So now just 2-3 examples what practically we are doing for Karnataka. I just try to explain. So Karnataka Forest Department is one of the pioneers. They are trying to use the latest technology for forest conservation and everything. So they use remote sensing, GIS very effectively, Karnataka. So we have established a forest fire monitoring and management cell. So it will like send the fire, detects the fire locations in Karnataka and give the information. So with the support of NRSC, it will do that. So NRSC will send the location so that system established by KSRSAC and KFD disseminate the systems officer. So it will ensure that the fire initiated is not spreaded. So last 3-4 years the system is working well. So the system is established after 2019. The Karnataka Bandipur fire incident happened. So after that, so there is a separate strategy team created the system part of Karnataka Forest Department support. So they have the reason behind with that. There's now completely automated system is established in Karnataka KSRSAC for supporting forest fire activity. So in part of it we try to use for drones something. Now this year we are also last 6 months we are fully involved in the drone related activities. So so we have procured drones for forest. So now basically the fire season will start now January month onwards. It will the fire vulnerability will be more due to the summer season start. So it will going to be started. Now they are using it for the vehicle this animal tracking. Everything. So Mysore for this elephant, leopard, everything they are using for they are safe and human safe and rescue. They are using it. So what is it we are planning? We are doing it for surveillance. So forest fire, what happening? It's mainly all fires are mostly man-made. Okay. If there is a people afraid first. So if there is a flying 2-3 times, a pre-flight happens. So the persons, anybody near going to forest, everything actually, they will get first. The fear will be created because somebody is monitoring. So if something, even fire happened, it will be captured immediately and the information will be given. So 4-5 divisions already having the system, but we cannot right now with the small number they cannot able to cover everything. That's why satellite is doing it. Satellite systems have 8 passes in a day, so it is doing that purpose. Wherever the gap is there, we are trying to utilize the drone for a forest, not the fire control, only detection. Fire control you need a larger system. So that system will be worked out later. So it will give the situation awareness. So the drones will give the any disaster situation awareness. So why it will very much useful to take the immediate correct decision in terms of rescue planning, in terms of next what is the next step for the management, everything. So they are using it. Yes. Yes. Correct, right. Exactly, sir. Even now, as we are speaking, 4 forest officials getting trained fully. for this purpose. They are even for getting pilot full complete. That pilot license certificate they are getting with the center. So 1 week training they undergone. They undergone already about the whatever topic they already did it. So they are using it. Some videos I will show the elephant detection how they are doing. Now they come up with more requirement. For speaker required some torchlight because to guide the elephant towards the forest. So it will help them. So we are telling now manufacturer to we are also now, that's why it is a beginning, we are learning. So how best we can utilize, then we can modify the UAV system, sensor, payloads in terms of that. Apart from the nevertheless, the remote sensing, so many sensors are there. So we are trying to utilize for agriculture, everything anyway that is will be discussed later. So post-fire analysis. So what the drone will do, it will give clearly the better accurate damages in case of disaster. So satellite will be able to give the some level of accuracy in the damage assessment, but satellite drone will give the more accurate and perfect results or numbers in terms of damage severity and damage assessment. So so it will be more handy when the drone comes. And as I explained that we are doing now currently using drones. Almost some 8 teams working in Karnataka parallelly. We are outsourced it. For all the quarries in Karnataka, more than 3,000 quarries they are covering. So using all our multi-copters only. So for current level of the quarries getting now measured using the DTM. Then so these are things. So not only the drone, the bathymetry also we are trying to use. So that both drones also part of the system. So we are working with that also. It will give us the so pre-level will be the Cartosat stereo data. It will give a elevation model around 2005-6 those days. So we will compare the total. So this is some quarry. You can see that. So the details of the elevation model we can able to get every detail. So every small differences can be measured. So you can estimate the volume of each minerals excavated perfectly. So this is now Karnataka, we are practically fully utilizing, fully optimizing and fully part of the system, governance system it is incorporated. So we will give that the previous, this level at 2006, same area now, this much. So I can see the so much area the excavation happened, everything can be quantified accurately. So it is helping this government of Karnataka for the encroachment, identification and defaulters in terms of loyalty payment. So every mineral every 10 has to be, the loyalty should come to government. So that is that depending upon these results, so the defaulters are getting accountable. So they will give the, so the actions are coming to the government. So yes. No sir, no private, we are not right now. So now, so we are in training also, only for data processing we are doing fully. But in terms of full this pilot training using a proper channel, schools, authorized schools, through them only we are doing it, sir. No, still private is not, we have not done, but all the government, so in Karnataka government body, state government body, with the proper channel requirement, it is supported. So that is policy level decisions, so I am not able to comment. Okay, so anyway, yeah, but depending upon sir, our workload also, it is there, so there has to be, we are not, majorly not actually a teaching agency. So, yeah. So, next now everybody now talking about the Yeah, I got it. So AA. Sir, yes, AA can be utilized. See, what we are doing is nothing but a AA with a limited tool, limited methods, limited procedures. AA will increase little bit, so AA can be used, no doubt. Because, but anyway, we have to train. So any AA tools we have to do a lot of training. With the training, we have to have a lot of inputs. So we can do that. It is so all software. What they are doing is basically a half AI, it is AI only. So the tools are working. So if the individual intelligence is if taken care, okay, so then the AI comes, actual AI comes. So there we have to still, we have to go little bit distance. So that, yes, obviously part of it. So you have to give a system of 2 input, automatically everything will be coming up. Yeah, it is possible if the No. See, any 2D maps cannot be may not be useful. You need a 3D. So you need a 3D. Right now, what is the best 3D available creation layers are topo sheets. Okay, but it have accuracy of compared to that. So topo sheet, one of the then aerial photograph taken at that time. Then satellite images. So Cartosat is we have started from 2005 May onwards. So we have a Cartosat stereo data. So yes, even if you go into the Corona stereo images available 1965, 75, we have even one set. So it is there for processing. So we can able to do that. So yeah, we are doing on that actually. So next we will talk about now the latest is everything is actually it's oblique sensor. If you talk about payload application. So what is oblique sensor is, it is having a 5 lenses. It is RGB sensor with it capture 5 angles minimum for 45-degree angle. So it will create in one single pattern flight. It will create it will cover all the. So it's covering a 5 angle images capturing. So it can able to create a 3D realistic model of a system. So this is Mangalore Corporation, they have did it. So now we are trying to use it for all the urban area. For this survey we are planning to do using the oblique sensor. So it is different from a normal RGB. It covers 5 angle with a 45-degree angle difference. So I can able to generate automatically a good build-up model with real photorealistic efforts. It will give me the proper measurement. So it is basically for property taxation. So 95 to 98 is enough. Yeah, so it is there. So if in case any dispute comes, they will do the ground survey. It is as it is. So if a dispute comes, see any remote sensing of photogrammetry, any error, the benefits of doubt will go to the user, whatever that he only get that, whatever the error of that bias they will get. Beyond that only government, even drone case also, we do the volumetric measurement. We will say this much is excavated. It will come with accuracy limit. So we will say this much 5%, 8%, depending upon that 3% we will say. So whatever that volume will not be considered. So it will be given to the benefit of the doubts will go to the other side. So remaining it is fair. It is far better system than nothing to prove. So it is approved. We are doing on that. So like that way government works. Sorry. They are going to use. So, but Bangalore already, not all the wards almost covered. Part of 5 land records. Okay, it is called LSM or UPOR project. Urban Property Ownership Records, UPOR project. E-Bhoomi is already there. Bhoomi system is already there. So it is not only Bhoomi, Bhoomi plus this is. No, we are not used. So we are now trying to use only 6-band sensor Altum PT microrelated. So 5+1 thermal for agriculture purposes. Hyperspectral sensor we are not at plant, but we are going to use, yes. But right now we are not having experience with the hyperspectral sensor in drones. Satellite based we are working on that. So this 3D model, tile model, so it will give everything, so we will get very beautiful. We can measure number of floors, plinth area, actual built-up area. So it's mostly helping for property tax assessment. So Karnataka Municipal Data Society, KMDS, they are planning to do for all the towns in Karnataka for property survey. It's a GSP property survey. It will support them for the proper measurement of properties in Karnataka. So this one, this Mangalore, what we are seeing. No, this is a model. This is a model. You can see that. It's a model. This is a model. It's not a picture. So if you have software, I can able to tell. Even you can wear a 3D glass. You can see the 3D. Okay, so anyway, this is we are doing it for. It will be used for disaster also. So landslide happened 2018 Kodagu. So some parts are covered. This is drone image. For this year, drone still for photography, but ortho imagery. You can see that satellite images before and after, same area. So how this is a permanently actually damaged. The debris, the landslide, it is almost permanently damaged the systems in that. So we can, that's why it will give more severity. Satellite will help us everywhere there is a landslide happen, we can map it. Optical sensor will provide it. Even micro data also using the radar interferometry we can do. But the severity, the detail level, drone will help us. So we can do that. So these are, it was done. So some few of ortho images I am just explaining. These are the things. This is satellite, same area, drone. So nothing was there. Everything is passed away. This is previous is a coffee plantation. It's previous, and this it was towards. So next previous one. This is agriculture land. Before it was this. Okay, so no. This is we are tracking actually. So I will show some. Forest department, they are using, this is elephant, they are tracking. So individual elephant, so they are having a system same Tunga, so they are using effectively a thermal sensor. So now they are having, they require some enhancement further, even their loudspeaker is required, anyway part of system, so we are going to build on that. So it will come next some group of. So if this current forest fire, we will be able to show something, same thing, group of elephants, so it can be. So here also some challenges will be there. If the forest is dense, even thermal sensor will not work well. So this is happened, I think, Mysore or Mandya, so they are doing it. So these are some applications we are working, I think. See, 500 meter, it will be very good. Up to 1000 meter, the range is fine. Fine. So it has a 4x digital zoom. So it is 1 kilometer range, the thermal sensor. They are uncooled camera, because for that they don't record actual measurement of temperature. So they don't require. There is a temperature anomaly is enough to say which is hot body. So that is the official enough, because it is unnecessary costly. So when the radiometric thermal sensor record, that is right now forest department, simple thermal sensor uncooled only working on it, so it is working very well. Still, even radiometric if working on very high dense forest, definitely they will go for it. So we are working on, but we are seeing that we are working on the technology because we know how the thermal emissivity works. So there is little difficulty even with radiometric sensor, but we have to work on that. See, night time it varies because of the it should separable the hot body. Okay, so the ambient temperature also matters to detect the hot body. So 1000 meter is even daytime you will be able to see the difference, but the exact the shape something will night you will get more clarity than the day. So there is a difference, no doubt, because it is the temperature anomaly with the ambient or background. That is the concept. So you will have a best up to 1000 meter range you will have. That's it. 1 kilometer, the range. Anyway, you cannot fly anything more than 120 meter height. So the range will be it. So any other questions?
Thank you very much, sir.
Thanks for that.
He is a person who is working on real-time projects for the government of Karnataka. So he will be having more experience. If any doubts, any queries, in future also you can contact us or you can contact him directly for clarifications. He will be able to solve your questions and give answers.
Yeah, happily do that.
Thank you very much, sir.
Thank you all. Thank you. Have a nice evening. Thanks.
So I request all of you to tomorrow be here at 9:30 sharply. We will start the sessions because the afternoon sessions we will be having at Presidency University, which is the demonstration and operations of the drone. We have to travel from here in the bus. So during lunch break, first 40 people who will finish early and come to the bus, we will take them first and later we will be guided. Okay? So be here on time and see you tomorrow. And how many of here will be staying in the guest house? Please raise your hands. Okay. Fine, thank you. See you tomorrow then. Those who are staying in the guest house, please let me know if any support is required from the academic staff. Dinner will be provided here. Don't go outside after 9 or 9:30. Okay? And do not go to the compound side where there is no solar lamp or electric lamp, because in the compound there are some snakes. So please